Hello, this is a video from the Sexton Corporation describing how to use a nodal finder with a machine vision or security camera. And basically that is to find the center of rotation of a lens to eliminate parallax in a underwater camera system behind a dome port. The base of the system is made from an aluminum 6061 anodized plate with a pattern of 1/4-20 holes. This here is a nodal finder slide from Really Right Stuff, and it has several points of articulation. This is a reticle from Thor Labs. If I zoom in here, you can see that there's a very fine crosshair. It's only 1/1000th wide, and we made a target in the back that is a white background with a 10/1000ths wide line of black marks. And they're interrupted so that you can line up the reticle in between them and still be able to have a little bit of contrast to make sure that you're lined up right in the middle of those marks. So the way this works, I'm going to demonstrate using this Basler security camera, and I have it hooked up to a computer so that I can demonstrate how I would go about finding the center of the new lens. So I've already pre-installed the base plate onto the security camera. The goal is to have it pretty well square and centered, and then this dovetail fits into this track right here, and then it tightens with this knob right here. So I'll get it most of the way tight so I have a little bit of adjustability left and right. So that's tight, loosen it a little bit, and then I want to move the camera. I can move it left and I can move it right, and the goal when I have it centered on my computer screen, I can see the reticle and I can see it lined up with the target in the background. So once I'm happy with the placement of the camera in a left and right orientation, so that looks pretty centered, then I'll tighten that knob down so that locks my left and right movement. So now all I have is forward and backward and rotation. Now the next step is to, on the screen, line up the reticle on the target so it's as centered as possible. And this is easier with a higher resolution camera, and these reticles could be changed out for ones that are a little bit wider if that's easier. But once I have the reticle lined up, then I can rotate the camera, and if I'm rotating about the axis of the camera or of the lens, then the reticle should remain lined up. So what I'm finding here is that in this position, and I can exaggerate it a little bit. So exaggerated, when I rotate, the center of the reticle is right here, but it should be lined up on that line right there. So I will back this up. And what I'm doing is I'm sliding the camera backwards because the entrance pupil is going to be right around where the aperture is located. And so as I back this up, I'll eventually get the center of the lens lined up with this 0 mark that's right here on this scale. So when I'm happy with the placement of the camera, I can lock this knob here on the right, and that locks my forward and backward movement, so I can no longer move the camera forward and backward. I can only rotate it left and right. And if I'm in the correct location, then when I rotate the camera left and right, the reticle should remain lined up on the target in the background. Again, with a higher resolution camera, there will be more contrast, it'll be easier to see. With a lower resolution camera, you may need to switch out the targets, but this is a good start for a very precise nodal measurement tool to eliminate parallax in your lens system.